Hello everyone, this is Unit 5, Day 1. Okay, I'm not too sure if everybody kind of understood yesterday's lesson, and being we're all virtual, I don't know what it's like looking at home, so I'm going to do a recording of both of these lessons, and hopefully that'll help you out. Okay, so in this one we're talking about sequences, right? So sequences can look a number of ways, right? In this case we're talking about arithmetic sequences. So what you want to know about arithmetic sequences is that they look something like this. Okay, so 2, 4, 6, 8, 10, 12. Okay, maybe it's 5, 10, 15, 20, 25, 30. Or maybe it's 36, 24, 18, 12, 6, 0, -6. Okay, all of these sequence of numbers have something in common. Right? First, they're a list. Okay, so you got to recognize that it's just a list of numbers, right? And so, and the list of numbers that are in this case going up by the same amount or going down by the same amount, right? In this case, we're adding 2. In this case, we're adding 5. In this case, we're subtracting 6. Okay, so arithmetic sequences look something like this. They're either going up or going down by the same amount. So arithmetic sequences are by nature linear. Right? And what do I mean by that? You know, if you remember linear equations, right? We have a slope. What does that slope do? Well, it's that average rate of change, right? What's changing each time? In this case, we're adding 2 or 5 or subtracting 6. And so that's what I mean by linear in nature, is that their average rate of change, or what they're going up by, is constant. Right? So arithmetic sequences have a common difference, okay, which means they, like I said, are just going up or going down by the same amount each time. Okay, so this is on your reference sheet. Okay, this is what the formula for an arithmetic sequence looks like. Okay, and this formula, what this does is it allows you to find any term in the sequence. Okay, so once you have this formula, which we're going to be doing algebraically and using our calculator, okay, what was I going to say? What you'll find is you can find any number in the sequence once you have this. Okay, so let's break this guy down for you. All right, so a sub n, so it refers the number to the nth term. Okay, so we'll just call it the nth term. All right, so when they're talking about find the nth term, what they're talking about is find the equation. Okay, and so what is this equation? All right, well, a sub 1 is your first term in the sequence. Okay, your n refers to the term in the sequence. All right, so the number, I guess. Okay, where that, what term we're talking about, either first term, second term, right? This would be considered our first term. Okay, this guy, -6, would be considered our 7th term. All right, so that's what they mean by first term or 7th term or 6th term. It's whatever number falls in that place in the sequence. Okay, and then finally, D is the common difference. Okay, all right. So anyway, I ran out of room there, but you guys get a common difference, okay? There we are, difference. So, this backup plan, okay, which I attached a PDF and a video of me kind of demonstrating linear regression. I'm not sure if I'm going to try to demonstrate that again in class. It's kind of difficult. I don't know if anybody pays attention. But anyway, you can utilize that sheet and utilize the video, and maybe pay attention in class when I'm trying to demonstrate it, in order to use this calculator trick as your backup plan, right? Because you should be able to utilize both methods, right? It's nice to be able to check to see whether you're correct, okay? But sometimes sometimes the question doesn't ask you to find it algebraically or using your. It just says find the sequence. So I think it's important to know how to do both, all right? When we're graphing these guys, okay, we want to use points only. That means we are not connecting the graphs, and so keep that in mind. All right, I know it's such a habit to connect the graphs, but we're not going to be doing that. okay? And then the domain and range are the list of values, not an interval, okay? So when we're talking about domain, right, they're going to be look in these squiggly lines here, right, which means we don't care about any values in between, just the numbers that fall in that just the numbers that fall in the sequence here, okay? So anyway, so it says graph the first 5 terms in the following sequence. All right, so here's our equation to the nth term, all right? So this equation can be utilized to find any value we want. So if we want the first term, okay, well, we substitute a 1 in there for that subscript, and then anywhere you see an n, plug in that 1, and so our first term in the sequence is a -4. Our second term, or a sub 2, plug a 2 in there, and end up getting a -1. Third term, we're going to get a +2. Fourth term, and get a 5, and our fifth term gives us an 8. So as you can see, we're increasing by 3 each time. All right, so let me graph these. Make sure you do not connect them. And we leave it as is, right? So it asks for what is the domain of the function, right? What is our input here? Right, well, our input is just in reference to whatever term we are talking about in the sequence here. Okay, so our domain, or our input, is just 1, 2, 3, 4, 5, ... right? Pretty much whole numbers, right? Or counting numbers, right? But anyway, so the numbers are infinite, so we can find any term we want in the sequence, right? Notice we start at 1, though, right? We want the first term, second term, third term, fourth term, right? And then our range is whatever our output is. Okay, so in this case, it's -4, -1, 2, 5, 8, and then so on and so forth, right? Because numbers are infinite, so make sure you put those 3 dots to let them know what's going on forever. Okay? And if you notice, we have all 3 dots in all of these to let us know that these guys are sequences. Okay? So anyway, the directions for this one. Now, I will skip this part here. Okay, be it that I'm just going to be writing on, the notability here. So this is on the video, or it's a PDF, okay? And I'll demonstrate in class as well, okay? But for this part here, let's just focus on the finding the arithmetic sequence algebraically, okay? So anyway, first part in all of these, we got to look and see, okay, which one of these is arithmetic and which one is not, right? And so what we're looking for is, again, whether they are increasing or decreasing by that constant amount, okay? So if you look at 2, right, looks like we're multiplying by 3 each time. And again, arithmetic is adding the same amount, not multiplying, okay? So this is not arithmetic. In fact, it's our next unit. It's geometric, okay? Which means you just multiply by the same value each time, okay? So just recognize the difference, right? Arithmetic, you're adding. Geo, you're multiplying, okay? That's the next unit. Just focus on the arithmetic. So, all right, so this guy's no good. And then also looking down here, I see that there's no way we could be adding the same amount each time. 1/2 to 1/8, right? 1/2 plus 1/2 would be 1, right? And so a quick trick you can utilize, to see whether or not you're adding the same amount each time, just go 1/8 minus 1/2. What do we get? -0.375. All right, and then we're going to go 132 minus 1/8. And that is a -0.093. 0.375. So as you can see, we're not going up by the same amount each time. From 1/2 to 1/8, we went up by 0.375, and from 1/8 to 132, we went up by that much. Okay, so this is not arithmetic as well. Okay, so the last ones are hopefully arithmetic, right? Which they are. Okay, I did that on purpose, right? So this is going to be +2. Oh, I'm sorry. Woo, not +2. Hey-oh, -2, right? We're going down by 2 each time. So this is arithmetic, right? And then this guy is going up by 5. So this is an arithmetic sequence as well. All right. Now, B involves using the formula. So remember the formula is this. We want to find the nth term using the formula. So you're going to start with your a sub 1, which is your first term. I'm going to move that d value to the front because that's normally where we keep things. All right, and so all we need to figure out or need to find is our first term and what our common difference is. And we have that, right? We got both of those things just looking at our sequence. So a sub n is equal to 10, right, minus, right, because we're going down, whoops, 2 and -1. Okay, and then the last part, C, we'll skip right there. D, all right. Now also real quick too, if you do use the calculator trick and you've already kind of looked at that or are comfortable with that, right, what you'll find is that what your calculator does is when it finds this formula, or it finds this equation, right, it substitutes that -2 in. All right, and so this one's going to be actually 12, whoops, I'm sorry, -2n plus 12, okay? That's what you would see in your calculator when you do the calculator trick. And the only difference between what your calculator does and what we do using the formula is just we're not distributing the -2. We can, right? I mean, makes things easier for you. It's all good, all right? But anyway, that's what your calculator does different. And anyway, so this one right here, we want to find the 10th term. So I'm going to use the one I got from the calculator, right, because that's a little easier. So -20 plus 12 will give me a -8. Shrink this down a little bit so all this stuff kind of fits. And there we go. All right, let's go down to number 3. So same thing, right? So it's arithmetic. We know what our first term is, so 6 plus, and it's going to be 5 times n minus 1. Using the calculator in regression, you will find that you're going to end up getting 5n plus 1, right, which is just this formula simplified. And then D, a sub 10 is equal to 5 times 10 plus 1. So our 10th term in the series will be 51. Okay? Do 5 and 6, we'll call it a day here. Okay? So number 5, all right, it's asking us to find the nth term in the following sequence. Okay? So, what it's asking for again is this equation right here. This is our nth term, right? Again, it's the nth term because look at our subscript, right? It's an n. We don't know, it's what term you reference to, right? And so this is a formula just generalized to find any term in the sequence, okay? So unfortunately, though, if you look, we don't have the first term, okay? So there's a couple ways you could go about this. You could do it manually, right? So if the fifth term is 19 and we're going up by 3, right, then this would be 16. Whoops, it's supposed to be a 3. This would be 13. This would be 10. And this would be 7, right? So our first term is a 7. But maybe you don't like that route, and as you can see, number 6, that route would take a long time, right? Especially, if this number gets bigger and bigger. So a way to kind of take care of that, shrink this down here. Okay? Way to take care of that is this, right? So we want the first term, right? So how do I get from 5 to 1? Well, our difference there is 4, right? to get down, we went down 1, 2, 3, 4 times, right? So we're going to go 3 times 4, which is 12, and then 19 minus 12 is equal to 7. So both ways get you there, right? I just think this makes a little more sense, this one on the right, because save you some time. Right, so now that we have our first term, okay, we plug it into this equation. So a sub n is equal to 7, and we're going up by 3, so plus 3 and minus 1. And then using your calculator, you would find that this guy is going to end up being 3n plus 4. Okay? So if you use your calculator trick, the regression on your calculator, that will be the answer you will see. Okay, and again, either watch me demonstrate this in class, or, like I said, utilize my video or the PDF. Okay, so lastly, right, this is why this trick works a little better for these bigger numbers, right? Because I don't want to have to do 14. I'm going to subtract 46 by 4 14 times. That sounds terrible, right? So I'm trying to get to the first term, which means I'm going to go back 13 times, right? And so in order to do that, I'm going to go 13 times 4, which is what, 52? Could be wrong. Oh yeah, 52. Okay, and then we're going to go 46. Well, I don't want to do it that way. But 46 minus 52, or 52 minus 46, will give me a 6. But remember, we're subtracting 46 by 52, so our answer here, so our first term, is a negative 6. Okay, because remember, we want 46 minus 52 is a negative 6. Okay? So anyway, there's our first term. So a sub n, the formula we're going to use is negative 6 plus 4 times n minus 1, because that's what we're going up by each time. And then again, when you use the regression in your calculator, okay, you're going to get 4n minus 10. Okay? All right. So I'll upload this video if you're watching it. Hopefully this helps. And good luck, you guys.